Okay, college algebra. Hopefully this works out okay. Found out I had a bad cord, so thought it was the mic, but hopefully this will work out. So we're dealing with inequalities, and we're going to start by talking about linear inequalities. And when we solve them very intuitively like you would equations. Negative 2x is less than 16. And when we divide by a negative, you have to remember that you must switch the sign. Remember, we switch the sign because if you consider, say, the number 1 and 5, and then number negative 1 and negative 5, 1 is less than 5, but negative 1 is not less than negative 5. In fact, negative 1 is greater than negative 5. So you can see when you're dealing with negative situations, that's kind of what happens, just due to the way our number line is structured. So when you represent the solution, though, that's the inequality, negative 8 with an open circle and an arrow to the right. That would be the graph. And then the interval notation would be negative 8, comma, infinity with a parenthesis. Now, I know that you're probably very good at solving those type of inequalities, but what if we end up with compound inequalities? Compound means more than one. This situation is a compound inequality. It consists of negative 9 less than 3x minus 7, and then 3x minus 7 is less than or equal to 11. So I add the 7 to both sides. I get negative 2 is less than 3x. Divide by 3, and negative 2/3 is less than x. Or you may think of that as x greater than negative 2/3. The next was we add 7 to both sides. You see that 3x is less than or equal to 18. We divide by 3, x is less than or equal to 6. So in this situation, as you graph your solution set, you plot 6, plot negative 2/3. Negative 2/3 open circle, arrow to the right. 6 closed circle, arrow to the left. You can see they come together. That makes it a conjunction. And the interval would be negative 2/3 with a parenthesis, and then 6 with a bracket. The next one is a disjunction. Notice that if you divide by negative 4, we get x is greater than negative 2, or as you add 3 to both sides, you get x is less than negative 5. Watch what happens as you graph this. Negative 5 and negative 2. X is greater than negative 2. X is less than negative 5. They go apart from each other. That's a disjunction. So the solution set is negative infinity to negative 5, union negative 2 to infinity. So use that union symbol to show that you're joining the two together. Okay? So that should be a lot of review. Another review piece for you are absolute value inequalities. And absolute value inequalities, those are a little bit unique. For example, if you look at this first situation, we have the absolute value of 2x minus 3 minus 9 is greater than 21. First of all, you need to isolate the absolute value. So absolute value of 2x minus 3 is greater than 30. Now, already I can see it's greater than 30. If you end up with a great or then symbol, I call it greater, that means you're going to have a disjunction. But if you ended up with a less than, then it's a conjunction. You know that it's going to come together. And you don't have to figure it out ahead of time, but it just kind of helps, tell you that you're doing the problem the right way. So let's look at this one. This is a great or. So I set up 2x minus 3 is greater than 30, and then 2x minus 3 is less than negative 30. So you make it negative and switch the sign. Add the 3. 2x greater than 33. Divide by 2. X is greater than 16.5. On the other side, we add 3, and we get 2x is less than negative 30 or negative 27. Divide by 2, x is less than negative 13.5. So if you look at that, within your solution set, negative 13.5, open circle, arrow to the left, and then 16.5, open circle, arrow to the right. And as you express that in interval notation, negative infinity to negative 13.5, and then union with 16.5 to infinity. We're going to look at another one here that involves absolute value. I'm going to press pause. Won't seem very long for you guys because the video would pick right back up, but I need to help somebody real quick. All right, so I'm back, and now if you look at the next one, we subtract the 2, and you get the absolute value of 3 minus x is less than or equal to 5. Now, that is a less than, and if you look at our information up above, less than should be a conjunction. This should come together. So let's see if that happens. I set up 3 minus x is less than or equal to 5, and 3 minus x is greater than or equal to negative 5. Subtract the 3, negative x less than or equal to 2. Divide by negative 1, x is greater than or equal to negative 2. Subtract 3, negative x greater than or equal to negative 8. Divide by negative 1, x less than or equal to 8. And so if you plot these, I have negative 2, and I have 8. I have closed circles on both, and arrows together. So the solution set in interval notation would be negative 2 to 8. So that's a less than situation. The other two are a little bit unique. We're going to talk about what they mean by looking at the notes up here. All right, think about this statement. The absolute value is something greater than a negative. Well, absolute value is a positive. And when is a positive greater than a negative? All the time. So if you end up with a negative on the other side of an absolute value, the solution is all real numbers. Any number you plug in would work. Suppose you end up with an absolute value less than a negative. That it's never possible for a positive to be less than a negative. So this is a no solution. This one says the absolute value should be less than 0. Well, that means it would be negative. So again, no solution. This next one is the same thing. Absolute value less than 0, no solution. But it says it could be equal to it. It is true that wherever the absolute value is equal to 0, you get one solution in that scenario. Absolute value greater than or equal to 0, that's always true. Negative infinity to positive infinity. But absolute value greater than 0, that is going to exclude one value. And that's wherever the absolute value of x is equal to 0. So see what I'm saying as you look at these next two examples, and I got to take a break here. But we're going to divide by 6, and we get the absolute value of x minus 5 is less than or equal to 0. Can an absolute value ever be less than 0? No. But we could have the absolute value of x minus 5 equal to 0. So when you solve x minus 5 is equal to 0, you just get x is 5. As you can see, one solution. If you look at the next one, we start by subtracting 18. We get the absolute value of 2x minus 3 is greater than negative 13. Uh-oh, I have a negative on that side. Can an absolute value be greater than a negative? Yeah, it's always greater than a negative. So therefore, my solution says negative infinity to positive infinity. Last example, we're going to flip over and look at what happens when we have nonlinear inequality. Okay, nonlinear means that you don't have x to the first power. We have x in this case to the second power. Or x to the third would be nonlinear. Or 1 over x would be nonlinear. It's not a line. And so when you have nonlinears, they're a little bit trickier to solve. You can't solve them like you do all the others. You're right that you subtract 15 greater than 0, and you're right that you set up x plus 5 times x minus 3 is greater than 0. But what you don't have, what you don't get, is you don't go then x plus 5 is greater than 0, and x minus 3 is greater than 0. As you solve that, you get x greater than negative 5, and you get x greater than 3. And that, just frankly, is not the solution set. At this point, you have one of two options. You either need to consider a number line test, Or if you don't do the number line test, you need to look at the graph. Let me show you the number line test. We take the solutions of -5 and +3, and we place them right here. And then we test numbers between them. See, -5 and 3 are what give you 0, but we want stuff that's greater than 0 or stuff that's positive. So I'm going to try a number. I'm going to try plugging in -6 because it's to the left of -5. And when I plug -6 in here, notice what I get. -6 plus 5 is a negative, and -6 minus 3 is a negative. And a negative times a negative is a positive. Now I'm going to try a number between -5 and 3. I like to try 0. So if I try 0 there, 0 plus 5, that's a positive. And 0 minus 3, that's a negative. Positive times a negative is a negative. Now I'm going to try a number to the right of 3. I'm going to try 4. So I plug 4 in. 4 plus 5 is a positive, and 4 minus 3 is a positive. And a positive times a positive is a positive. So the question is, where do we get a positive result? We get a positive result here and a positive result here. So negative infinity to -5, union with 3 to infinity, is my solution set. It turns out that for quadratics especially, there's sometimes a way that people like to solve it that's easier. You make a graph and you plot your -5 and your 3 that you came up with over here. And because it's a positive x squared, you know that the graph goes up. Well, the problem says, where is it greater than 0? What does it mean to be greater than 0? It means that you are above the x-axis. Here I'm above the x-axis. I'm positive. Here I'm above the x-axis. I'm positive. But here the graph is below the x-axis. It is negative. So where is it positive? From -5 on over and from 3 on over. So you can see that your solution set is still negative infinity and -5, union with 3 to infinity. I think solving nonlinear inequalities is the hardest part of this next unit. One of these lessons we're going to have to do in class because it does get rather complicated. But I think that as long as you work hard with it and ask questions, you're going to do just fine. See if you can at least get started on the linear and then the quadratic representations in your homework. Good luck. Let me know if you need help.